Okay, data file is just more like sending a text file, more like sending a text file. There's no jitter there. It's more like you're just sending an email. You're just sending an email. The only thing that will make a file delay, maybe it's when the internet is cut. Then the loss is also, it's just 0. Then bandwidth, it's the same with a compressed video. Then we have a transaction, which is 2 to 3 seconds delay. Jitter, not jitter, no loss, no loss. Then the bandwidth is 10, I mean, same as, the bandwidth is 10, I mean. Availability and reliability. Availability and reliability. What does it mean by reliability? Reliability. The probability that the network will not break down over a period of time. Clients will need something reliable, not all the time that the network is down. So as the network engineers, you have to put in place, you have to make sure that there will be no errors of doubt, because we're not going to have business. We are talking about the competitive world where you have to make sure that you win the competitive advantage to fit the market. There are people, there's competition. There's competition in all angles of life. If you don't make sure that you put yourself there to be on the market, then there's nothing for you. You look at what is happening everywhere. It's competition. It's unfortunate that there are only some few parastatals, especially for the government, that you are not even competing with anyone. We talk of ZESCO. There is a lot of laziness. There's a lot of doing whatever they want, because they're not competing with anyone. At the end of the day, I don't even know why they advertise. I don't even know if they have a marketing. They're marketing for what? Because they're the only ones. So we have also the instantaneous availability. This is the probability of network being available at a given time. If you say the internet will only be available 18 hours, yeah, that's fits to be instantaneous availability. Then we have availability now. The fraction of time that a network will be available over a given period of time. Okay, let's say 24/7, the availability. And this also will determine also how you are going to have the client, because we look at the availability. This network all the time is off, or this one is at least it's on all the time. So as network engineers, you have to put these 3 into consideration. Cost of downtime. This will vary, okay? This is just an example. We can give our own. Let's say if a certain service provider is down, they're going to lose money. In finance, if ATMs are down, of course, they are going to be on the loss. So we have finance, media, retail, they all have their cost downtime. So this table gives an indication of cost per hour of downtime, but actual values depend on the size of a company and the exact nature of a business. Leonard Euler's number. So E appears in several calculations performed by network engineers, including availability and reliability calculation. So it is briefly explained. E is called Euler's number, not to be confused with Y, which is Euler's constant. That's thing like I. So E is irrational. It is not a ratio of integers. That is, it cannot be expressed in the form of minute. Sorry. Hello. I can hear you. So M, that will be in minutes. Then that is in nanoseconds, like 1/2 or 2/3. So it's a transcendental. It is not a root of any non-zero polynomial with a rational coefficient. So if A, B, C, and X are all rational, there is no formula such as AX2 plus BX plus C, etc. This is equivalent to E. The value of E truncated to 10 decimal places. We have that graph on the right hand side. E is the unique number. A such that the derivative of the exponential of the function. F Ex, that's a formula. At the point of X, and we'll do this, the function of E is called the exponential function, and it is inverse, which is a natural logarithm of logarithm to base E, to the base E. We'll look at this, I think, in topic 3 or 4. Exponents, raising a number to a power. So this slide is provided to aid understanding of the various formulas that involve raising one number to the power of another. We have to the power of x, the power of minus x, e, the power of x, e minus x. So these are just some of the formulas we are going to be using when generating and converting and explaining the traffic from the graph. At the end of the day, when you design a network, when the network is slow, you need to find out why is it slow? Why is the graph below? Why is it below average? You have to give the explanation in terms of the documentation. Some of these graphs, it's not everyone. Let's say we have people who are non-technical and people who are technical. People who are non-technical, they are not going to understand anything, not until you can explain it into the language that everyone is going to understand, into the language that everyone is going to understand. No wonder last week we talked about the modeling. It's very important to model the network, not just the network. Even in software development, you do model the software development. So we have other formulas like mean time between faults, mean time to repair, then T stands for time period. So we have such formulas. Exponents calculators are available. Let's say if we need these calculators, you can find the calculator following this link. There's a link below there. You can find the online calculators, because we are not going to use our normal calculators and try to find answers using our normal calculators. Follow this link. Let's hope we all have the notes.
Not yet.
Oh, you don't have the notes? Okay. After this, text me your email address. I'm going to email you. I'm going to email the notes, everything.
Okay.
Yes. So these are the example, the graphs shows the days. We are going to find our own graphs as we start running our own OpenNet, our own Riverbed. Just make sure that your machines are faster.
Sorry. Just a quick question.
Okay.
With the graphs and the formulas, like how much of that is involved in the whole course?
It's just about formulas. We'll be generating graphs, these type of graphs. No wonder you keep seeing these graphs. You know, we use a formula. These formulas you see are used to generate these graphs. But in Riverbed, in OpenNet, you don't need to enter the graphs. You are somehow a bit like, because you're not writing any exam, any theory exam. But if it was a theory exam, you are expected to know all these formulas, because it's maths related. You have to perform them. But in Riverbed, you just have to enter you configure the network, you enter the application, the metrics, then we'll show you how to generate these graphs. But what you do is now to interpret.
Mr. Chintu,
Hello?
is this course going to involve any subnetting?
This one won't involve subnetting, but there's a related one which will involve subnetting. Let me just say let me just say it involves subnetting, but you won't subnet at this stage. There will be a stage where you are required to subnet, learn the IP addresses, classes of IP addresses. You should learn how to convert the decimal to binary, binary to decimal to hexadecimals, and also to learn IP addressing, supernetting, all those things.
All right.
Okay. So all these are just worked examples. These are just worked examples. We'll find our own where we can do exactly. These are just examples. Okay, there are more examples. Effect on reliability of mirroring of components. We know what it means by the mirroring. So let's say two servers, each one has MTBF, which is equal to 1000, MTTR, which is 24 hours. Application requires that only one need to be available. Instantaneous availability of one server, A, is equal to 0.9766. Availability of any one of the two. Then we have 1 minus 1 in brackets, dash 0.9766 by, so you can calculate and it will give you that answer. These are already worked examples. If you've got calculators at your own time, you can also try to find out if they have these examples have given you the correct answers. So the probability that at least one is available, probability that both will be in fail state at the same time. So A is equal to 1 would mean 100% available. Or available means it never fails. 100% means that the server will keep on running all the time. Will keep on running all the time. But we have to put it in calculation. What will make this that our server will be 100% available? Some more examples. That one is talking about the CPU, Ethernet card, a cable, a router, all components need to be working to achieve communications. CPU just to be connected to the network card, NIC, then just to be connected to the cable, Cat5 or Cat what, then to the router. Then definitely a router supposed to be connected to the switch. Like a router will be connected to the switch. So you can just come up with the figures just to make sure that you work things out. They just don't want you to write it in the cell. No, the server is 100% or it's not going to be a fail. But you can put it like that. Let's say if you introduce a redundance. We know what a redundance is. Big servers they do have a redundance. If one cable fails, or a power cable or a network cable, meaning that the other one will still keep running. So we need to configure. So this network technology, I know they are going to ask us to design a certain network. They're going to ask us to design a certain network, but they'll ask us what measures can you put in place for these networks to be running all the time. So I would want before the courseworks, actually I would want before the courseworks are out, we are going to use the odd courseworks where we can do these courseworks in a space of two weeks together. We finish it up so that you see what goes on. So when the actual courseworks are out, you don't struggle to work on these courseworks. Just make sure that this week everyone has got OpenNet running.
Okay.
Yes. Performance analysis, we have when, what? When, meaning that we are talking about the initial design in operations. When do we do the initial design? When do we do the operation? When do we upgrade? Upgrading like user needs. The users, they will tell you what needs to be upgraded. If it's a link, it needs to be upgraded. If it's a technology, the devices need to be upgraded. If it's what, so we do things according to the user's needs. We are just you are just the developers. At the end of the day, you are just doing this for the end users. So you need to follow the requirement specifications or the specification. Even in software development, we get the requirement specs from the end users. Then you just design according to what the end users have told you to do. When we look at the life cycle in software development, there's a certain phase where we need to collect the requirement specs using the fact-finding techniques or using the gathering tools. Then we have what predicts performance. Identify problems. You need to identify the problems in order for you to design what the end users need. Then you have to, when you identify the problems, you need to now suggest the improvements. Then you have to test the proposed changes. So this is what is involved in coursework. So you are given a coursework, you are given a scenario, then they'll ask you now. You need to identify the problems. You need to now suggest the improvements. You write it in, put in a certain task. Then those things that you have written, you have documented. Now you have to design a network according to what you have put on paper. Okay. Why do performance problems occur? A lot of things. Overload is one of them. Let's say we've designed a network. This network is for about 100 people. Tomorrow we have 500. That's overload. So overload will cause a temporary congestion, sometimes permanent congestion if you are not going to find a solution. Then we have inappropriate choice of links. Inappropriate choice of links. You know, if the network is big, huge, you need bigger links. Smaller links, they can't cope with the traffic, okay? Even the equipment also. Then components failure, e.g. router. If the router is down or the switch is down or the link is down, this will cause a problem to the network. Of course, it will cause a problem to the network. Also, lack of planning for application in use. Lack of planning for application in use. Lack of planning for application in use. Let's say you need to plan the traffic profiles. You need to plan the best traffic. You need to plan the statistical multiplexing. So everything is about planning. Planning is modeling. We're talking about modeling. You have to model the network. Then simultaneous reboot. All the time the network or the switch is rebooting, the router is rebooting, that will cause a problem. Then broadcast storms, poor tuning, buffers. You know what it means by buffer? Meaning that the network is slow, it will keep on buffering, then timeout. The transmission, packet size. The recommended packet size. If the packet is bigger than that recommended one, meaning that the network will be failing. Then we'll talk about the window sizing. All these falls in TCP/IP protocol suite, 7 layers, where we have to talk about the protocols that are found at each and every layer and the functions of each protocol. The functions of each protocol. Then monitoring performance, performance monitoring and configuration inspection tools include ifconfig. We know these commands. I know you know these commands. Ifconfig, this is interface configuration. ARP, this is address resolution. ARP stands for address resolution protocol. Then ping stands for what? Or at least tell me what's the use for, tell me the use of a ping.
To see if the host to see if the host can reply.
Okay.
Or if it's online.
Yeah, true. So it's more like a shout out. Hello, are you there? In BlackBerries, we had also this service. PING stands for Packet Internet Grouper. Packet Internet Grouper. Then we have a trace route that will show you the path taken. Then that will show me from this host how many hop counts are in between. Then we have NetStats. This will show the packet statistics loss rate. Then OmniPeak. This show packet statistics protocol. OmniPeak is a software that will show you the packet statistics and protocols. Then NSLOOKUP, it's a DNS queries, domain name service or domain name system. So consider all the troubleshooting, find the bottlenecks. You have to consider all the stages in the source destination path. When you are troubleshooting can be very difficult than designing a network starting from the scratch. Troubleshooting can be very difficult. So in troubleshooting, you are considering all the stages in source destination, then test or eliminate each link component systematically, then check hardware or software configuration. Then modern protocols are designed to reduce or avoid congestion, but they need to be fine-tuned. They need to be fine-tuned when we are troubleshooting until you find the error. Performance prediction techniques, there's measurement, mathematics with the queuing theory, then we have simulations. Simulations, e.g. using OPNet or NS2, but us, we are using OPNet. Then the balance between cost, performance, and reliability. In cost, we have to consider the cost of hardware, the cost of software, the cost of staff, the cost of installation, and the cost of maintenance. Okay. Then performance, we're looking at the quality of equipment. Okay. The quality of equipment will contribute to the performance. Quality of design also contribute to the performance. Then configuration settings also. Then reliability, we're looking at higher quality equipment, security measures, and backup mirroring redundancy. Okay, these are network performance examples, parameters and examples. We look at the characteristics, characterized traffic, packet per second, packet interval time per second, packet size, bits or byte per second. The network capacity will depend on the network components. The links, the capacity will depend on the links, servers, routers, switches. It is if they do have limited capacity to transmit or process the traffic, then the capacity is measured in bytes per second, or bits per second, or packets per second. But when we're configuring, always pick bits per second, because bits is smaller than all of these. Performance measures, load. We can measure the performance using load, using its throughput or its utilization. You can use the delay variation, packet loss. Utilization is equal to load over capacity. Load over capacity, which could be 70% or less. If the load is less than capacity, or is well. But if the load is greater than the capacity, things are not well. Okay? Right, then we have utilization. We know utilization is utilizing the link. What you utilize a link is depending on the load. Let's say a link, R is equal to link bandwidth, link speed, e.g. R is equal to 10 megabytes per second, load on the link, which is 6 megabytes per second. Link utilization is equal to load over capacity. We have 6 over 10 is equal to, it will give us 0.6, which is definitely 60%. For a traffic flow or specific packet, the time interval, T is equal to interval time, A is equal to arrival rate, interactive time, interval time, it's packet per second. PL, we are talking about packet length, PL, packet length. Transmission rate or transmission time is equal to packet length. Then we can say, let's say 100 megabytes per second is equal to 1,500 bytes, which will give us 12,000 bits. Then the time, the transmission time, which is 12,000 as we see it, which is 12,000 over 100 million, is equal to 0.0012 seconds, which will give us 12 nanoseconds, 12 nanoseconds. Then utilization is transmission rate, interval time, which will give us arrival rate, packet length, as well as a link bandwidth, We have to know these TS. We have to know that TS, we're talking about transmission time. TA, we are talking about interval time. Okay, PL, we are talking about packet length. A, we are talking about arrival rate. Then R, we are talking about the link bandwidth, Okay. Then we have link speed rate. R is equal to 100 megabytes per second. Of course, it will give us that much. Then the utilization, it will give us what we have already. It's already been worked out. Okay, this is just an example of a network. We are going to design something like this. Okay. Do we still have time? Today it was supposed to be 1 hour. It was supposed to be 1 hour today. Supposed to be 1 hour. We are about, anyway, we're almost done. Let's just finish it. We're almost done. We're almost done. Service level agreement. This is what I told you about SLA, service level agreement. This is where the client and the provider will come up with an agreement. It's not all the time that the providers are the one on the wrong. You have to sign, this is more like an agreement, a form, whereby if someone violates the agreement, you can take them to court. Even the service providers can take you to court if you violate what the service level agreement you say. So this service level agreement, it has goals like availability. So our goal is to make the global IP network available to customers, free of network outages, meaning that 100% of time. So since the service level agreement says 100% availability, if you don't receive this as the clients, you have got the right to take them to court, okay? Because they have violated the law. Then we have the latence. You know the latence. The latence is some form of a delay, okay? So the latence says the average monthly latence speed of North America global IP network will not exceed the 50 milliseconds round trip. Transatlantic average monthly latence will not exceed 90 milliseconds round trip. Trans-Pacific average monthly latence will not exceed 130 milliseconds. If it exceeds these figures, you have to take them to court. They have to pay you back for the loss, okay? Then packet loss, they say the average monthly packet loss liability of the global IP network will not exceed 0.1%. You have to be taking this into account as the network people. If it exceeds this, then you are going to have a problem there. It's either they refund you the money that you paid for that particular month, or you don't pay for the next month. You just have to agree. You have to make sure that these things in the agreement, they are not met. Just like a landlord-tenant agreement, okay? There are such agreements. Then we have jitter. The average jitter on the North America global IP network would be, let's say 0.25 seconds. If it exceeds that, then you have got all the rights to take them to court, okay? Then you can even give them the graph. This is the delay we had, like this, you present to them. Then they'll have to acknowledge, okay? Then we have Ethernet utilization and so on. Do you have questions? Do you have questions? Any questions? Okay. I've recorded this session. We can end it today. So what I'll do, I'm going to send you the link on YouTube. You can watch it over and over again. That's what we'll be doing for all the sessions we'll be having. They will be recorded so that those who are not in class, those who are missing, they can actually follow the YouTube.
Yes, just
Okay.
one thing I've just remembered. Today we were supposed to discuss
The
the
time.
Saturday meeting.
Okay. So what time can we meet on Saturday?
After 10.
After 10. So after 10 is what time?
Maybe
10:01.
10:30.
Okay.
Because the earlier the better. You know how Saturday can be.
Okay, 10:30. Okay, we agreed 10:30, right?
Yes.
So it's just
Thank
Okay,
you.
between 10 and 10:30.
all right. Okay, that's fine. Okay. Have a good night.
Thank you.
Good night. Thanks.